stream of mine, some of you guys were curious as to how I actually authenticate the user work. So think of this as like the basics of user auth. So what do we actually do? How is it stored and stuff like that? Do we store the string in the database as some of you guys were talking about, or what's done? So uh, here's a quick refresher on that. So I have a database called YT that has a table called user, and the username is a primary key on ID, right? It's public dot users. So let's say I want to, our traditional approach might be actually inserting a record like this, right? So the ID is one, the username is noob, the password is password, right? So this is what a traditional approach might look like. And the way authentication would work on your app is I have a really simple Go app here that establishes a database connection using the Postgres driver, runs the query, select password from users where username is one, right? And the password is scanned into a string for the user noob. And we know the correct password. We ask the user the password. If both of them are correct, the user is logged in. If they are not, the user is not given password. So the correct password is password, the user entered password, hence we are logged in. But the obvious issue we run into here is uh, if I open up my database, you will see that we are storing the password as plain text, which is tethered to the privacy of the user. Let's say our database gets hacked or something like that. To put it briefly, this would be really bad for users. So what is instead done is there is something called a bcrypt hash used. So let's edit our program to reflect that. So let me first delete that. Delete uh, from users where username is. So now hopefully we have nothing in users. So okay, now we can get on to our magic. So uh, let's just say we want to first store the user noob, right? How do we do users? The values ID, comma, username, comma, password, comma, that, right? We need to do that. And we can actually execute this by from the DB connection, uh, dbcon dot uh, execute query one comma no comma password. So this is how you would do it. And if the error is not nil, we would panic with the error, right? Okay, what would you return? Mm, okay. Mm, you want one more? I don't want one more. Okay, so that is what this returns. We are storing the password as is. Instead, what we'll do is we will use something known as hashing. So hashing, a hash function is a mathematical function that returns a unique value for every input and hashes very widely, right? So the correlation between the inputs, show you an example of this. So let's just say the actual password to store, right, is password, right? Let us actually hash it. So the hashing is provided by a library called bcrypt that we actually have to install in Go. So so to do that, the easiest way is to just let Go's mod handle it, right? So we call bcrypt, that is in golang.crypto, and we say generate from password. We convert it into bytes and we use the default cost, right? So if error is not nil, panic with the error. If else, print the hash password, and for now, exit from the program. And yeah, we don't actually have it installed. So running a quick mod td will install it for us. that's instant. I know none of that is used. So right now, if I go run dot, you'll see that this is our hashed password that is in the form of runes, if you may. Now, this hashed password is the password that we will be storing. So instead of this, we'll be passing the hashed password. And let's okay, let's not do anything and run our program. Go run dot password. You'll see that the correct password is this random string that we do not know the answer to, and it would not be an easy task guessing the string. Number File has made an excellent video on it that I recommend you check out. But now you see that when we are passing in password as the argument, even though we have stored a hash of the password, it's not able to determine whether it's correct. So what you actually have to use a function that bcrypt itself has provided. So you can compare the hash and the password, right? So we can compare. So what does this take in? Okay, this takes in a byte of password and a byte of user. And what does this return? It returns an error. So if that is nil, we are logged in. And if it's not, we are not logged in. So now if I pass in the password, oops, we are still inserting. We don't need to do this now. We don't need to do this. Okay. So now if I run that, you'll see the correct password is the hashed. The user has entered password and we are logged in. Now if I check my database, uh, select everything from users, you'll see that the password is hashed. So there's no way we know about it. So that's how you store passwords and authenticate users. So authenticate, that is if you're using a traditional email password approach. So hopefully you learned something new. Thanks for watching. And if you like this form of quick bits content, let me know in the comments. I'm planning on trying these out. So thanks for watching.